So this is the first lecture in our content on the basics of experiments, and it turns out this is quite important content for understanding everything else we're doing, so hopefully it'll all make sense to you. It's well aligned with the chapters in your online textbook. So this lecture will probably highlight for you more than any other lecture the difference between objective science and indigenous perspectives, or even most qualitative researchers. So in this experimental paradigm, the research is objective. The researcher is distancing themselves from the subject of their research. It's one directional. The researcher observes with no direct feedback to him or her from the earth. So it's one directional. And by taking that objective stance, the researcher hopes to discover truth. Subjective research and much qualitative research, some qualitative research is bidirectional. The researcher engages with participants to arrive at truth together. And so we don't have the researcher putting a lens on this individual. We have the researcher engaging with the individual they're studying, and the individual they're studying informing the researcher. So whatever approach seems right and best to you, that's for you to decide. And what this content is for is to make you well informed about what experiments are, where they might be most useful, and where they might not be the optimal way of discovering truth. So we talk about uppercase theory, lowercase theory, and hypothesis. So theory in the uppercase, well, actually begin with theory in the lowercase. We use these words informally. So this kind of theory is just like a guess about a reason we have for some phenomenon. Like, I have a theory that the reason I've been sleeping so badly lately is that I've been viewing screens at bedtime. So this is just like the way we use the term informally. We have an idea, maybe an educated idea, about why something might be occurring. A hypothesis is a specific prediction about the result of an experiment to test a theory, usually grounded in previous research. So I hypothesize that people who watch screens at bedtime will have longer delay in sleep than people who don't watch screens at bedtime. And you can see that there's sort of a prediction here for something that might reasonably be tested. And then an uppercase theory is a broad conclusion that's drawn from the results of many experiments that all had similar findings. So like the theory of attachment or the theory of evolution. And the reason we still call them theories, even though all the results show the same thing, is that it is still possible that some new study could show evidence to the contrary. It could still be disproven. And so even if there's tons and tons of evidence, we still look at it as a theory. In the Good Samaritan study, we might think of this as the loose theory might have been like perhaps one of the researchers noticed that when he was stressed and running late, he was less attentive to other people's needs. Maybe someone even called him out on this, and since he saw himself as a compassionate person, he was surprised at his own behavior. The hypothesis, the research hypothesized then that people would be less helpful to a stranger in need if they were under time pressure and stressed. And the uppercase theory that's been pretty well established is that helpfulness to others is driven by situational pressures more than by individual characteristics. We also have the lowercase experiment and uppercase experiment. We do use these words informally. So the lowercase experiment is just an informal way of exploring a particular phenomenon, usually without an intention of contributing to scientific knowledge. So I did a little experiment to find out which food my dog likes best. Just means that we gave the dog different kinds of food and looked at which ones they ate most quickly or whatever we were deciding to measure. A true experiment, or an uppercase experiment, is a formal test of a hypothesis following specific parameters to ensure that a cause-effect relationship can be established. And this is the only way to demonstrate causation in the research paradigm. So if we want to show that a new medicine we have actually helps control an illness, we need to do a true experiment. And that's what this content is about. So as we stated in the previous slide, experiments are the only way to demonstrate causation. So causation, again, referring to whether one factor impacts another factor. And experiments have two key characteristics, a manipulation or a treatment. The researcher has to manipulate the independent variable. You'll recall that the independent variable is the phenomenon that the researcher thinks will impact the dependent variable. That was covered in last week's content. And that might involve giving a medicine or treatment or experience to some participants and not to others, and then measuring some outcome. And the second is control of extraneous variables. The researcher must control or minimize variability in extraneous variables. And these refer to just variables that aren't the independent or dependent variables. So that's what extraneous are. And of course, we're going to cover these more. True experiments also rely on some sort of random assignment, in which participants are assigned at random to either receive the treatment or not receive the treatment, or assigned at random when to receive the treatment. In medical research, we call these randomized clinical trials or sometimes randomized controlled trials, and the acronym is RCTs. And they look like this. We have a number of patients who all share some condition, let's say a similar level of heart health. Using the dice throw metaphorically to randomly assign them, we randomly assign some to be in a treatment condition where they receive a new medicine, and some to be in a control condition where they receive a fake medicine that looks like the real medicine but isn't. In this case, the independent variable is the medicine, and the two conditions are whether it's the real medicine, the experimental condition, or the fake medicine, the control condition. And then we measure heart health. We can see in this case the dependent variable is heart health. The researchers hypothesize that heart health will depend on whether participants take the real or fake medicine. And so here we have in the top condition with a new medicine, we have better improvements in heart than we do in this lower case with the medicine that was fake or that was the placebo. So that's the randomized controlled trial or randomized clinical trial, the only way to demonstrate that a medicine really creates a difference in the symptoms it claims. So we have treatment conditions in experiments, and typically experimental conditions are assigned to two or more conditions: an experimental condition in which they receive the real treatment, or a control condition with a fake treatment or no treatment. In this case, you can see this simple example of a researcher who's interested in the impact of music, or distracting sounds, we should say, on their performance on a test. And we can see the participants are in identical situations. The classroom, the lighting, everything is identical, except for one thing. The experimental group has this loud music in the background, and the control group doesn't. That allows the researchers, if it's a well-designed experiment, to determine whether the test group, whether the loud music will impact test scores in some way. So independent variable conditions can have a couple of different designs. So the first is this single factor two-level design. And so just because in research, as in statistics, there are so many ways of referring to the same thing, factor is just another way of saying variable, and level is another way of saying conditions. So we could also say this is a single variable two condition design, but the term that's used more commonly is the single factor two-level design. So in this case, we have the independent variable, the two random conditions, experimental and control, and the dependent variable. The independent variable is divided into only two conditions, and so that's why it is a single factor just one independent variable, and the two conditions, the experimental and the control conditions, make it a two-level design. This was the case for the testosterone gun study that we talked about last week. Participants either played mousetrap or assembled a gun. Hence, we had one independent variable, the activity in which participants participated, and two conditions or levels. A multi-level design, you can see, is very similar to the two-level design, except we have three conditions, or we could say three levels. And the example of the smoke-filled room study, depending on which variation you're looking at, will suggest that there were sometimes three levels or conditions. Either the participant was alone in the smoky room, with a confederate in the smoky room, the confederate who was unconcerned, or were with two other naive participants. And so this was a multi-level design, in this case a three-level design. So we also have different types of control conditions. We could have a no treatment control condition in which participants in the control group just do what they would normally do, no intervention. We could have a placebo control condition, and the placebo is that fake medicine. We'll talk about this condition a little bit later in this lecture, in the next lecture. Just so you know, if there is a situation where a medicine is being tested and some people are given a fake medicine and it turns out that the real medicine is effective, then generally those people who were given the placebo would receive the real treatment after the experiment is done. There is a waitlist control condition in which participants are told they'll receive the treatment, but they have to wait until the participants in the treatment condition have already received it. And there are comparison conditions in which there's no placebo, but participants are given an alternate treatment to those who were not received the real treatment. So we'll tease these out just a little bit on the next slides. So this first example is the no treatment control condition. An example is taking a test with and without distracting noise, and you can see that the control group takes the test with no difference in their environment or no treatment. A comparison condition control is comparing phobia, which is a deep anxiety-producing fear of a particular thing, and there are, let's say there's a common way of treating it, and a new way that some researchers want to explore. So they might compare their new way, let's say that is the progressive exposure to whatever the individual is afraid of, in this case snakes, and a traditional treatment, flooding, which is on the left here. So the participants in the control condition would receive the typical treatment rather than no treatment. The waitlist control condition is one in which individuals will all get the treatment, but the participants in the control group will wait. So this has a delayed time factor. So if you look at the diagram on the bottom, you can see that a bunch of participants are going to be treated. I'm offering that this is to treat eczema, which is a skin condition. So let's say we have some sort of a cream to treat this, and we tell all the participants so that they don't worry. We tell them they're all going to get it. But the people who are assigned to the treatment group get the cream right away and use it for the first 2 weeks, as shown in stage 1. The people in the WLC group, or the waitlist control group, just wait during this period, knowing that they will get the treatment at the end of the 2 weeks. At the end of the 2 weeks, where these two vertical lines are in the center, both groups are tested to see what their eczema symptoms are like. If at this point, at the end of stage 1, we have an improvement in the treatment group and no improvement in the wait group, we can, start to feel confident that our intervention, our cream, is working. If, however, both groups have a similar improvement at stage 1, then we know that these symptoms just passed in a matter of time and that it wasn't the intervention that was making the difference. Of course, in stage 2, we can gather follow-up data on the treatment group and gather intervention data on the WLC or the waitlist control group.